All right. So we're gonna start with tangent graphs. So and if y'all can write notes as we go, either on a sheet of notebook paper or on your actual notes if you're able to print it. So one thing to remember from before is that tangent of x is equal to y over x on the unit circle, right? And just to refresh our memory, since it's been a while, the reason why tangent is equal to y over x, if you're on the unit circle, and let's say you're over here at a 60-degree angle, um, then this point would be, what would this point be? You can, I guess I can't really ask. I can ask this.
Half comma pi
Unmute
over
yourself.
2.
Okay. It's what you said?
Isn't it half comma square root of 3 over 2?
Yes. Half comma square root of 3 over 2. Very good. And so what that means is that the distance from here to here is 1/2, and the distance from here to here is square root of 3 over 2, right? And what is this hypotenuse right here going to be?
1.
1. Okay, because it's the unit circle, right? And so when we're talking about the reason why this is cosine here, 1/2, is because cosine is adjacent over hypotenuse. This is a refresher for us. And this, right, if we're talking about this angle 60 degrees, this is our adjacent, 1/2, and our hypotenuse is 1, right? And so cosine is just 1/2, which is why this is 1/2 here. Okay. For sine is opposite over hypotenuse, and the opposite of this angle 60 is square root of 3 over 2, and the hypotenuse is 1, so that's square root of 3 over 2, right? And so that's why sine we can just think of as the y value. Everybody good with that?
Yes.
Yeah.
If you can give feedback via voice like that, or if you can shoot a message on the chat for everybody to see, that would help as we go. So that's just a refresher on why cosine is sine. And then tangent, which is what we're talking about today, tangent is y over x because tangent is opposite over adjacent. And if we're looking at this 60-degree angle, the opposite is square root of 3 over 2. And the adjacent is 1/2, right? And so what you are dividing there is, at the top, you have square root of 3 over 2, right, which is your y. And at the bottom, you have 1/2, which is your x. And so it's always going to be y divided by x. Or we can think about, because y is sine, I'm running out of space here, is sine over, what would be at the bottom?
Cosine.
Cosine, very good, because
Cosine.
cosine is x, right? So that's why tangent is equal to sine over cosine, and tangent is equal to y over x. So that's the first thing we need to know here, because that's what we're about to jump into. Okay. The last thing to take note is tangent is going to be undefined, where cosine of x equals 0. Tangent is going to be undefined, where cosine of x is equal to 0. Okay. Here's why. That eraser does not work well. How do I make this eraser bigger? Let's do that. Don't worry, I'm gonna get the stray marks for those of you who get annoyed when I leave all the marks. Okay. So tangent is undefined where cosine of x is equal to 0, because wherever this equals 0, you're gonna have 0 on the denominator, right? And if you divide by 0, it is undefined. Is everybody good with that? Any questions so far? Hello? It says that my internet is a little bit slow, so I want to make sure everybody saw or heard that. All right. So let's take a look at tangent now. So what we're doing is we're looking at what is the tangent graph going to look like. Okay, so we know what sine graph looks like and we know what cosine graph looks like. Generally, sine is going to start at 0, 0, right? And sine is going to look like that. And then it's going to keep going, so on and so forth. That's the sine. And then generally cosine is going to be start at 0, 1, and it's going to go like that, right? So those are the general sine and cosine graphs. So we're looking at what would tangent graph look like, okay? So what we'll do to kind of figure that out is plug in x values for tangent and see what the y value is, put that on the graph and see what it looks like, and then talk about the features of it, okay? So we'll start with tangent, and then we'll go to cotangent, and then we'll go to cosecant and secant, and that will be today's lesson. So it's a little bit more in depth today. We're going to talk about 4 functions, okay? So let's say we want to plug in negative pi over 4, okay? For tangent, we're going to have tangent of negative pi over 4. And we're trying to figure out what that is equal to. And remember, for tangent, tangent is y divided by x, right, on the unit circle. So we're going to go on the unit circle, just kind of do a rough sketch. We're going to be down here, negative pi over 4. That point is square root of 2 over 2, comma, negative square root of 2 over 2. And if we're dividing y divided by x, that's negative square root of 2 over 2 divided by square root of 2 over 2. Now, instead of keep changing, flipping here, we can just see that square root of 2 over 2 divided by square root of 2 over 2, because they're the same, it's just going to equal 1. It's like saying 4 divided by 4, that's just 1, right? So because these are the same, it's just 1, but then we have this negative, and so because you have a negative, it's going to be negative 1, okay? So tangent of negative pi over 4 is negative 1, all right? And again, pause me at any point if I'm going too fast. I see there's a little bit of a lag with my writing and my talking. And if there's any question you have, send a message. If you're writing and you don't have like the physical notes to type in, I know it's a little bit harder to follow along. So just pause me at any point if we're going too fast. So if we graph that on here, if this is 0 and this is negative pi over 2, negative pi over 4 will be halfway between there, right? Because as a reminder, pi over 2 is here, pi over 4 is over here. So it's halfway from 0 and pi over 2. So we are going to put it right here, negative pi over 4. And then there's going to be a point at negative pi over 4, comma 1. Okay. Negative pi over 4, comma, I'm sorry, negative 1. Negative pi over 4, comma, negative 1. Okay. And we would just continue like that with the rest of the values there. So we would plug in 0. So tangent of 0. If we think about 0, 0 on the unit circle is here. The point is 1, comma 0. And y divided by x would be 0 divided by 1. So that would be 0, right? And so that means there will be a point at 0, 0. Okay. So we need enough points to kind of form what the graph will look like. Okay. Then we're going to plug in pi over 6. So tangent of pi over 6. So on the unit circle, that is over here. That point will be square root of 3 over 2, comma 1/2. And since we're doing tangent is y over x, so in this case, we would actually kind of have to divide them. So it's 1/2 divided by square root of 3 over 2. It's y over x. So that's 1/2 times, keep, change, flip, 2 over square root of 3. We can cross these out, 2 and a 2. You just have 1 over square root of 3. When we rationalize this, you multiply by the square root of 3 over square root of 3. So it's going to be the square root of 3 over 3. Okay. Now, in this case, we don't want, usually we want it as a radical, but in this case, we don't want it as a radical because you want to be able to plot it on the graph, and you need a decimal to plot where square root of 3 over 3 is on the graph. So I'll put this in the calculator to see what it is as a decimal. And let me do that in my calculator here on my computer. I don't have my Inspire with me. If anybody has an Inspire at home, you can put that in and help us out real quick while my calculator's loading.
Wait, can you hear me?
Hello?
Hello? Can you hear me?
I can hear you, yes.
Okay. What, you know how I sent you the link about the calculator?
Yes. Yes, thank you for reminding me. I need to send that out to everyone. Thank you for reminding me, Sertanvi. Sertanvi sent a link for, apparently TI Inspire is providing free calculator software for 60 days, I want to say it was, where you can download it on
6 months.
Oh, 6 months. Okay. So for 6 months, where you can download it for free and you can get access to the computer software. It's just on the computer, right?
Yeah.
Okay. Awesome. So that's important. And I'll send that link that Sertanvi shares. Thank you for reminding me, Sertanvi. So that is a great thing that we can use. Okay. So we put that in and it was, I put it in, it was 0.577. So that means we're going to have a point at pi over 6, comma 0.577. So pi over 6, where's pi over 6 going to be within here?
The first little tick mark.
Okay, very good. And the first tick mark, because pi over 6 is 30 degrees, right? And the pi over 2 is 90 degrees. So this would be pi over 6. And then we're going to go up a little bit more than halfway because it's 0.57. Taking note that the 1, it's going by 0.5s, right? Each hash. So it's a little bit above that first hash. Should be like about right here. Okay. So we can kind of see some stuff forming. Now let's plug in pi over 4. So if we plug in pi over 4, it'd be tangent of pi over 4. Now we want to look for shortcuts. So like if I'm thinking about tangent of pi over 4, we're thinking, okay, pi over 4 is over here, right? And it's square root of 2 over 2, comma square root of 2 over 2. Every one that involves a divided by 4 for the radian means that it's in one of the 45s. And one of the 45s mean the x's and the y's are the same. The only difference is the positive and the negatives. So if we divide y divided by x, this divided by this is just going to equal 1, right? Because we have square root of 2 over 2 divided by square root of 2 over 2 is just going to equal 1. So every 45 should either equal 1 or negative 1. So that's a shortcut. So this is equal to 1. So pi over 4 is going to be right here because it's halfway between 0 and pi over 2 and 1. Okay. Now let's do pi over 3. Okay, so tangent pi over 3. So if we do tangent of pi over 3, pi over 3 is our 60 degree. That's going to be 1/2 comma square root of 3 over 2. And tangent is y over x, so we're doing square root of 3 over 2 divided by 1/2. Keep change flip is going to be square root of 3 over 2 times 2 over 1. These can cross out, is going to be square root of 3. And we want square root of 3 as a decimal so that we can see exactly where that's going to go. As a decimal, it is 1.7. This is 1.7. We're at pi over 3, which is right here. 1.7 is going to be about right here. Okay. And then got 2 more to plug in, and then we should be able to see generally what the shape is going to look like. Okay, so let's do pi over 2. So let's say we plug in pi over 2. So tangent of pi over 2. Pi over 2 is 90 degrees. So 0, 1. Tangent is y over x again. So we have 1 divided by 0. And what is 1 divided by 0 going to equal?
Undefined.
Undefined, very good, because you can't have 0 on the denominator, right? So this is undefined. If it is undefined, I want you to think about this for a second. If it's undefined, what would that mean we're going to have right here at pi over 2?
A whole.
Good thought. It could be a whole, but where would we put that hole?
A vertical asymptote.
A vertical asymptote? Why vertical asymptote? I don't know who said that.
Because it's undefined.
Because it's undefined, yeah. And it's undefined, like anywhere you plug in pi over 2, it does not exist, right? For a tangent. And it's not at a specific value, it's at every value for pi over 2. So we're going to be missing pi over 2, so we're going to put a vertical asymptote right there. Okay? So that's undefined. Now, that's important to note the fact that we have an asymptote at pi over 2, okay? Because anytime we divide by 0, it is undefined, right? This is important to understand. So really what that means is anytime that this x is 0, then we have an asymptote, which means really anytime that cosine, because cosine is x, anytime that cosine is 0, because tangent is sine over cosine, anytime that cosine is 0, you're going to have an asymptote. So where else on this graph would we also have an x of 0 that we would be having tangent being undefined?
Negative pi over 2.
Very good, negative pi over 2, because negative pi over 2 would be down here on the unit circle. That's 0, negative 1, right? So we're going to have an asymptote here. Where else? Where else are we going to have an asymptote?
3 pi over 2.
3 pi over 2, good, because 3 pi over 2 is going to be over here, right? And that's, again, 0, negative 1. And then past that 2 pi, we would be going into multiple rotations, right? But so we would still have asymptotes as we keep going. So there's going to be asymptotes as we go throughout this. And there's kind of, if you think about the unit circle, there's 2 places where cosine is 0. It's up here, 0, something, and it's down here, 0, something. So therefore, you're going to have an asymptote anytime we're from here or here, even if you have a multiple rotation, right? So we could be going around like this, and that's going to be an asymptote. So what is the distance between this up here? Let me do a different color. What's the distance between this and this? In radians, with the angle.
Pi.
Pi. So that means that you have an asymptote starting at pi over 2, right? And then you every distance that you go of pi on the x-axis, you're going to have more asymptotes. So if you kept going another pi, you would have another asymptote, and so on and so forth. Okay? That's the tangent part of the tangent graph. So so let's say we plug in pi, okay, for tangent of pi. Tangent of pi, that's over here. It's -1 comma 0. And again, tangent is y over x. That's 0 over 1. It's going to be 0. So at pi, we're going to have 0. And so what we should notice is we should notice a pattern, okay? The pattern, thank you, Claudia. I just saw your message on Remind. I got you. The pattern is that every pi, like between this, let me use this between this, that's pi, is going to be 0, right? So the next one over here at 2 pi is going to be 0, and so on and so forth, because it's just rotating around multiple times around the unit circle, okay? So, and then if we try to connect the dots right here, then we will be able to see is what is formed is it kind of looks cubic, it's kind of curved. If we were to plug in enough points, you'll be able to draw it perfectly. But generally, it's going to look something like this. Something like that, okay? So that is going to be the tangent graph. However, that is going to repeat multiple times because you can do multiple rotations. So it's going to be like that over here as well. Now, if I want to draw this more accurately, let me rewind back for a second. If I want to draw this more accurately, then what I can think about is where it's 1. Okay, what I mean by that is at -pi/4, it is -1. At pi/4, it is +1. So if I want to kind of graph this a little bit more accurately, I can go right here to the left pi/4 from that. And I can just put that at -1. And then I can go to the right pi/4 from here. And I can just put that at 1. Just if you want a more accurate graph, that's going to be a good way. All right, bye, Michael. This video will be recorded, and I'll upload it to YouTube. Try to do it after this, so that y'all can access it later, and for those who couldn't make it. So, all right. So then that's going to be like that, and it's going to continue 2 pi. We'll have that. This one would have that. So on and so forth. That's what the tangent graph is going to look like. Beautiful. Generally, this is teaching this to kind of. Oh, okay, bye, Julissa. I see your message. So generally, for calculus, it's important that you kind of know these functions. So the most important thing is that you know what the functions look like. And so just knowing if I say tangent, you know the graph is going to look like this. That's the most important thing kind of for calculus as a baseline foundation. So let me pause there and ask if there are any questions with respect to the tangent function. Did I lose anybody anywhere? If there are no questions, you can just say we're good, or you can respond on the group chat saying no questions, or if you have a question, send the question in. I'm gonna give everyone a minute to if you have any questions, because I can't see your faces, so I don't know what the good thing about this is that it's recorded as well, so you can also kind of go back and if a certain part but you didn't get. Okay, let's talk features. Let's talk features. If what I see so far, no questions. Oh, that's not good. So when I switch the slide, it takes away the writing there. I need to. Okay, I'm just gonna have to write it here then. It was domain period. Just talk features of the graph, asymptotes. range, amplitude, and amplitude and symmetry. Okay, so this is just some of the features of the graph here. So domain for this graph, remember domain is from left to right. So if we're looking at this, we're looking at, okay, where does it start on the left? Where does it end on the right? But we need to think about this in terms of section. So let's just look at this middle section here first, okay? If we think about that middle section, it does go, it has boundaries, right? The boundary that's keeping it is negative pi over 2 and pi over 2. So really, it goes from negative infinity to infinity, but the only places in which it's missing is these asymptotes right here. And so instead of saying, because you would have to write that forever, it goes from negative infinity, negative pi over 2, negative pi over 2 to pi over 2, pi over 2 to 3 pi over 2, 3 pi over 2 to, the next one, so on and so forth. You wouldn't want to write it like that because that would be forever. So instead, you would just say what x is not equal to. So x is not equal to pi over 2, right? We have an asymptote at pi over 2. That's talking about this one right here. We have an asymptote at pi over 2. And then we can think about, okay, where's the next infinite amount of asymptotes going to be? So to go from one asymptote to the next, we're adding how much?
Pi.
Pi, good. And so therefore, we can say it's pi over 2 plus pi. And then we can have pi's going this way. We can have 2 pi's, or it can be going the other way, and then you would be multiplying by -1. So what would be a way we can write a general equation? So if we say pi over 2 plus pi, that's only talking about the next one.
Pi x.
Good, pi x, or let's not use x just because we have the x here. I know what you mean, but instead of x, let's use
Pi n.
Let's do pi n, yeah. So that would be where our domain would be. X is not equal to pi over 2 plus pi times n. N could be any integer. N has to be an integer. The reason why I say integer is because integer is any positive or negative whole number. Because if we start to plug in numbers here for n that are not whole, then we're going to get decimals, but that's not going to give us all the asymptotes. So it has to be an integer, okay? All right. Our period. Now, period is defined from one peak to the next when we talked about sine and cosine graphs, right? So like, for example, the period for this graph, this sine graph, would be 2 pi, right? In this case, we're defining period as from one asymptote to the next, okay? Because from one asymptote to the next is when you will have went around to the next undefined. So in this case, our period would just be pi. Okay. And our asymptotes really are going to be similar to our domain. Our asymptotes are x equals pi over 2, right? That's where our asymptote is, plus pi times n, because that's where all of our asymptotes will be. And n, again, is any integer. Okay. Our range is all the y values that are possible. So in this case, the lowest to the highest. So our lowest is negative infinity and the highest is infinity. And that's the case all across the board, right? So the range, you can have any negative value, any positive values. So our range will be from negative infinity to infinity, okay? Amplitude. As a reminder, what amplitude is, amplitude from the perspective of sine and cosine graphs is half the distance from the top to the bottom, the maximum to the minimum. So like in this case, our amplitude is whatever this is, which is 1 in the case of our parent functions for sine, right? So in this case, when we think amplitude, it's going to go up. It's not going to stop. It's going to go up forever. So our amplitude, we could say is not applicable, or we can say it has no amplitude. Either one of those would be fine for this case. So you would have no amplitude or none, or not applicable, okay? And then symmetry, the type of symmetry it has would be origin symmetry, okay? Because every point that you have, like let's say you have the point over here, 1, 1, you're gonna have a, or sorry, this is 1, 1. No, that's not 1, 1. That's pi over 4, 1. I'm sorry. If you have pi over 4, 1, you're gonna have an opposite point over here, negative pi over 4, negative 1. Every point is gonna be on the opposite side of the origin, so that's gonna be origin symmetry, and it is an origin function. I'm sorry, not origin function. I'm sorry, odd function. I said origin function. Odd function is when it has origin symmetry. Sorry. So that is the tangent graph. That is why it looks the way that it does. That is the features that it has. Let me pause there before we talk about cotangent. And again, this lesson is a little bit involved. Any questions thus far, comments, concerns? You can just respond. Okay, good questions. Okay. All right. Next, I want to talk. We already did that. All right. I want to talk about cotangent and how that relates to tangent and what the graph looks like. So on the left side, we have tangent. On the right side, we have cotangent. So for tangent, we said tangent was y over x or sine over cosine. Let's just kind of fill out the main ones that are not decimals, which are going to be the quadrantal angles, right? So just remind me, and you can turn off your mic for this, and just kind of answer this through, because we don't need to draw the unit circle with this. What's 0 on the unit circle going to be as an ordered pair?
One comma 0.
Okay, thank you. Pi over 2.
0, comma 1.
Thank you. Pi.
Negative 1 comma 0.
Okay, 3 pi over 2.
0 comma negative 1.
And then 2 pi.
1, comma
1
0.
comma 0.
Okay. So thank you. If you're trying to kind of draw the tangent, and you don't remember what it looks like or whatever, you want to start with those. It's the same thing with sine and cosine. You start with those because those are going to be the kind of helpful for the maximum and minimums and for the asymptotes and things like that. So then you're gonna so if tangent is y over x, you would just divide, right? So for the first one, be 0 over 1, that would just be 0. So tangent of 0 is 0. So then you have a point at 0. Okay. And then you do the same thing here. 1 divided by 0, that's going to be undefined. So then at pi over 2, we're going to have an asymptote. And then tangent of pi, 0 over 1, it's going to be 0. So at pi, we're going to have 0. So you see how this is kind of going to be helpful to get kind of some of the main points if you can't remember. Those are the distinct features there. And then this one is going to be negative 1 over 0, which would be undefined. So you're going to have an asymptote here. And then this is going to be 0 over 1, which would be 0. So at 2 pi, you'll have 0. So that kind of gives you kind of a rough basis to which you can graph your tangent. And then, so it says basically if sine of the angle equals 0, so if sine is which is at the top, if the top is 0, then it's going to be, sorry about that. Let me put this on airplane mode. Okay. Hello? Oh, it's not working. It's frozen. Can y'all see my screen now? Sorry. On mine, it's showing.
It's frozen.
It's frozen, right?
It's frozen.
Okay, give me a second. Oh, you can't put it on airplane mode while doing that. You have to have Wi-Fi on. Y'all still there? Hello?
Yep.
Yeah.
Okay.
Yeah.
So I lost my iPad. Hold on. Let me. Sorry, y'all. Sorry about this. Give me a second. Can y'all see it now? Hey, hold on. Sorry, y'all. Let me pause the recording real quick. So cosine equals 0. And that's when the denominator equals 0. So then tangent will be undefined, right? Any questions? Okay. So basically, and then the other thing to note is tangent of pi over 4. So tangent of pi over 4 is equal to 1, right? Because square root of 2 over 2, comma, square root of 2 over 2 is the point. And so then you can kind of know that means at pi over 4, you're going to have point at 1. At pi over 4 from the pi over here, we're going to have a point at 1. And then same thing to the left. If you go to the left pi over 4, to the negative, you're going to have a point at negative 1. And kind of that's how you would have enough to sketch your graph. Okay. So that's generally how you would how you graph the tangent. Now, how that relates to cotangent is basically it would be the opposite, because remember cotangent, it flips. So if tangent is y over x, cotangent would be x over y. So then if you're looking at this first one, 0, and you have 1 comma 0, instead of y divided by x, you would be doing x divided by y. So it would be, instead of 0 over 1, it would be 1 over 0. So now this would be undefined, right? And so now your asymptote for cotangent would be at 0 instead. Okay. And then your asymptote, and then the same thing, everything would flip, right? So then like pi over 2, if it was 0 comma 1, if you flip it, it would be, I'm sorry, if it's 1 divided by 0 over here, cotangent would be 0 divided by 1, that would be 0. So then now at pi over 2, you would have a point at 0. And so you should be able to see a pattern. It goes from 0 to undefined to 0 to undefined to 0. So this one will go undefined to 0. Then the next one will be undefined, 0, undefined. So you'll have an asymptote at pi, point at 3 pi over 2, 0, an asymptote at 2 pi. Right. Now, in terms of the graph, however, the graph of cotangent, when you connect your points, is going to be a little bit different, slightly different. Okay, well, let's just talk about this real quick. Sorry, rewind it. so this is the opposite. If cosine is 0, now we're looking at the top, then it's going to be 0. If sine is equal to 0, then we're looking at the bottom. If you divide by 0, it is undefined. Okay. All right, so looking at the cotangent graph, it's going to be slightly different because now when we're talking about cotangent of pi over 4, okay, if we're thinking pi over 4 is over here on the unit circle. That's square root of 2 over 2. Square root of 2 over 2 is a point. Instead of doing y divided by x, we were doing x divided by y. But if you divide x, which is square root of 2 over 2, divided by y, which is square root of 2 over 2, if you divide those two, square root of 2 over 2 divided by square root of 2 over 2 is still going to equal 1, right? And so then when you plot that on the graph, pi over 4 and 1, what we notice is now it is starting from a decreasing perspective as you go from the left to the right. So when you graph this now, like if you were to go over here, another pi over 4 to the right, it will be at -1. And so this one will be going down like so. Okay. Because cotangent of pi over 4 is the same thing, is equivalent to tangent of pi over 4. So like this point right here on the tangent is still going to stay here on the cotangent. And because of where our asymptotes are, it's going to cause it to decrease. And this point right here on the tangent is going to still remain where it is on the cotangent. Okay. And so basically all of them like are going to be going down like that. And then we would have another asymptote over here. It would be going down like that. So that's generally what the cotangent graph would look like. Now let me pause there and see if you have any questions before we talk about the last two. Or comments or concerns. You can message on the group chat or you can unmute yourself and kind of share comments, questions, concerns. Or if I'm going too fast and I need to slow down because you're trying to write notes, you can message that. Or if you need to message me privately because you feel shy to ask a question publicly, you can do that on Zoom as well. Just give everyone a minute to respond. Okay, so far I have seen I'm good. I didn't hear from everybody, but I'm assuming you agree. So we're gonna talk about the last piece here, which is cosecant and secant graphs, okay? So for these, we're not gonna plug in all the points, we're just kind of explore. Firstly, thing to remember is that cosecant of x is equal to 1 over sine of x, and this is on your formula sheet. The reason why that is because if you remember cosecant and sine are opposite of each other. Sine is opposite over hypotenuse, and so therefore cosecant is hypotenuse over opposite. And if we kind of just, this is very important to know about for next class, that cosecant of x is equal to 1 over sine of x. So this is, if you just plug in sine of x being this, and we kind of just do the math here, 1 divided by opposite over hypotenuse. And this would be 1 over 1. And you keep change flip, so it'll be 1 over 1 times h over o. It will be h over o, which is cosecant. So this is called reciprocal identity. Cosecant equals 1 over sine of x. That's really important to understand, kind of just going forward. So this is the proof as to why, but cosecant of x equals 1 over sine of x is what we would need to know here, okay? So that is going to help us with the graph, okay? So I already provided you with the graph this time, okay? So if you look at this, we have sine of x, which is what we've been familiar with and kind of working on. Sine of x is the dashed graph here, okay? So this one, right? Sine of x always starts at 0, 0, right? This is the original parent function, always starts at 0, 0. Its next point, that is the maximum, is over here at pi over 2, 1, right? Then the next one that's easy to tell is pi 0, and then so on and so forth. And then the period is 2 pi. We can see the period is 2 pi. That's the original sine graph, okay? Any questions so far? Now, the cosecant graph is the one that is solid. We can see that it has asymptotes. And let's kind of talk about why. So it has to do with this formula here. Cosecant of x equals 1 over sine of x, okay? So let's say we start right here, and that's at 0, 0, okay? And we're trying to find what is cosecant of an x value of 0, okay? So cosecant of 0. So we can see where the cosecant graph would be. That would be equal to 1 over sine of 0, right? I can see there's a little bit of a lag there with my talking and my writing on my screen. I don't know if it's like that for y'all, so I'll kind of pause for a second. But so sine of 0. If we just look at the graph here, sine of 0 is 0, right? Sine of 0 is 0. So this is equal to 0. And 1 over 0 is undefined, okay? Which is why for the cosecant graph, we have an asymptote there at 0, okay? So what we can do is we can kind of just go along and do that for every value, just to kind of see why the graph looks the way it does. So let's say, for example, we were at pi over 2, and we plug pi over 2 here, and we plug pi over 2 here. 1 over sine pi over 2, sine of pi over 2 is equal to what?
1.
1, right? That's right here. So 1 over 1, and 1 over 1 is 1. That is why on this cosecant graph, it's still at 1, okay? And then you go to pi, and let's say you try to plug in pi, cosecant of pi is 1 over sine of pi, and sine of pi is 0, and 1 over 0 is undefined, which is why you have an asymptote.
See what you're writing.
You can't, oh, I'm sorry. There's a lag because of my internet, sorry. Thank you for letting me know. We good now?
Yes.
Do I need to go back and explain it? Because like you weren't able to see it, or but based on seeing it, we're good.
We're good.
Okay. So basically, it follows this pattern where sine is 0, like in this case, where sine is 0, cosecant will have an asymptote, and that will go all the way across. So like, let's say you're at 2 pi. At 2 pi, sine is 0, right? And so cosecant will have an asymptote. And then wherever sine is equal to 1, like in this case right here, sine is equal to 1, cosecant will also equal 1. And so you can kind of sketch the graph like that. So that is how you would do cosecant graph. Now, as a general, if I wanted to just graph this, I didn't want to plug in every time. So one way is I can think about this formula. See, it's still lagging, sorry. Let it catch up to me. So one way is I can think about that formula and kind of just plug in 0, plug in pi over 2, plug in pi. Or you can do a rough sketch of the sine graph. Like so. That's sine. And then after that rough sketch of the sine graph, then you can just, anywhere you see sine is 0, you know that if you put sine of 0 there, it's going to be 1 over 0, which is going to be undefined for the cosecant. So anytime you have that, you do a cosecant in a different color, you would have an asymptote. And anytime where sine is 1, you would actually have a point at 1. And then we would keep going. Sine of 0, you would have an asymptote. And then this one would be like this. And then here you would have a point. And at the next one over here, you would have a asymptote. And basically so on and so forth. And that would be like enough to kind of do a general graph. And I see it's lagging again. Okay, let me pause there. Any questions on cosecant? We got one more to talk about, secant. Thank you, Julius. I see your comment. So any questions, comments, concerns, confusions? All right. If so, we will talk about the last graph here then. Secant, which as we can see looks very similar, right? So let's kind of talk about this one. So as a reminder about the cosine graph first, which here in this case is dashed. This is our cosine graph. The cosine graph is dashed here. Remember, cosine starts at 0, 1, okay, which is what we see here. And so it's basically the same concept. So secant is equal to 1 over cosine, right? So therefore, wherever cosine is equal to 0, secant will be undefined. And wherever cosine of x is equal to 1, secant will be equal to 1. So looking at this, I can see, okay, cosine is at 0, 1. So therefore, I'm sorry, cosine is equal to 1, so therefore secant will be 1. That's why it's the same there. Here, cosine is equal to the y value of 0, and you can't do 1 divided by 0. That's undefined, so therefore you have an asymptote there. And so it's a similar concept, is basically just moved slightly to the left, right? Any questions on that? Thank you, Hugo. Any other questions? Comments, concerns? Okay. So this is just a graph of them next to each other. So you can see they look very similar, the secant and the cosecant, just slightly moved, right? Give you a minute to just kind of look at that. Sorry. All right. So just to recap, kind of make sure we remember all of them. If we're doing tangent, then tangent will have asymptotes at pi over 2, and then pi away from that. So it has a period of pi, right? And then at pi over 4, it'll be at 1. Negative pi over 4, it'll be at negative 1. It's like that. That's how, and then so on and so forth. That's tangent. So that's just quick graph of it. So just based on what we talked about, just graph it like that. It doesn't have to be perfect, just like that. Cotangent, if we were graphing that, where is our asymptotes for cotangent? Remind me. Hello?
Pi and 2 pi.
Say that one more time.
Pi and 2 pi.
So pi and 2 pi, yes. And 0.
0.
And then so now the point pi over 2 is 0, right? And then the slight difference here is that at pi over 4, the point is going to be where?
1.
1. And so this one is going down, right? So that's the cotangent. And then that's just a general sketch of the cotangent, okay? Then we had cosine, or cosecant, I'm sorry. And so when we want to graph cosecant of x, we know cosecant of x is equal to 1 over sine of x. So sine of x starts at 0, 0. And then pi over 2, 1. And then pi 0. So then we kind of just, let me do this dash. Oh, that was terrible. There we go. Something like that. That's it's hard to write on the iPad. That is a cosecant of or sorry, that's sine of x. Cosecant of x, remember, if we plug in 0 here, it's undefined. So wherever is 0, there's an asymptote for cosecant. So like right here, is going to be asymptote for cosecant. But if we plug in 1, it will be 1. So that's possible, is going to be right there. 0, asymptote. So then it's like that. -1 would still be -1, because 1 divided by -1, -1. 2, I missed it over here. This is supposed to be over here for the, sorry. So over here we have an asymptote. And so on and so forth, right? This one will be over here. And so that would be the graph of cosecant. So this is just quick sketches. Lastly, secant of x is equal to 1 over cosine of x. And so you just do a rough sketch of cosine. Cosine starts at 0, 1. Then pi over 2, 0. So it's like something like that, right? And then if we think about, is the same concept where cosine is 0, secant is undefined. And so like if you're drawing the secant graph, here is 1, that's going to stay 1. Here is 0, there's going to be an asymptote for secant. Here's -1, that's going to stay that. Here's 3 pi over 2 is going to be asymptote because that's at 0. And then here's that 0, there's an asymptote over here. And so this is the graph of secant, a rough sketch. And that is tangent, cosecant, secant, and cotangent graphs. That is a lesson for today. Thank you for showing patience with me still figuring out this technology. Thank you for tuning in on Zoom. And any questions, last minute questions, comments? We'll talk next steps. Any? You can turn off your mic or you can type. Got you, Kevin. All right. So I see no questions. Here's kind of next steps. I put a practice on Google Classroom. The practice is not really like it's not really that much new. I just want you to get more practice on the functions. And so what I want you to do is try to do this without your notes. And so you would just, you can study your notes first, and, you know, but you would graph all 6 of them. So you would graph the sine one on here, answer the features, the cosine one on here, answer the features. And then you would do that for secant, cosecant, so on and so forth. So you can just practice knowing how to graph them, okay? And practices will generally be due Friday. So the kind of just a plan, we can talk about this, but so one, attendance will be just like this. So it'll be, and we need to talk about time, take another, but attendance will be, let me pause to stop the recording so that